Welcome back to the Automation Podcast. My name is Shawn Tierney here from Insights in Automation. I want to thank you for tuning back in this week and I actually wish you all a very happy 2026. Happy New Year, everybody. I actually wasn't able to get into the office last week. Midweek, I came down with a really bad cold. I was sneezing. I was coughing. I had a fever. So that's why there was no show last week. So I bumped that one to next week. And so we didn't miss anything. We got several episodes already recorded and we got some great stuff coming down. I got a lot of vendors in the books, vendors you've asked me to reach out to, coming on as well. So we're going to have a great year this year for the Automation Podcast. We're also going to be changing things up a little bit. I'll do a separate video on that because I really want to focus on this week's episode today. And that is an episode in which I sit down with Matthew and Stefan from PRONETIQS to talk about their software. They got some great stuff that monitors your control systems, your control loops, and help you maintain your systems, help you maintain peak efficiency as well. And I just thought it was so easy to use. And I also thought the conversation was very interesting on how they use math and their vast backgrounds to come up with this new solution. So I really think you guys will enjoy this episode. And without further ado, let's go ahead and learn all about PRONETIQS in this week's episode of the Automation Podcast. Matthew and Stefan, thank you so much for coming on the Automation Podcast. It's great to have you guys on. I know this is your first time on the show, and I'm really looking forward to learning about your company and product. But before we get into all that, let's go ahead and first introduce yourself to our audience because, of course, this is your first time on the show. So let's go ahead and start with Matthew. Matthew, could you introduce yourself to our audience?
Absolutely. My name is Matthew Dulcey. I am a co-founder and the current Chief Technology Product Officer at PRONETIQS. PRONETIQS is a Rotterdam-based company here in the Netherlands. I myself, however, am not Dutch. I come via America and moved over here to Europe in 2013. I currently live in a small town near here called Delft.
Nice. And Stefan, could you introduce yourself to our audience?
Absolutely, Shawn. First of all, it's a pleasure to be here. So thank you very much for the invitation. My name is Stefan. I manage a team of data scientists. We share a common mission, and that is to provide data analytics solutions for industry. So we typically analyze data from industrial machines to tell people how they can run their machines more efficiently with less downtime. Nowadays, of course, we have to use the term artificial intelligence here. There's no avoiding that. Traditionally, we've been doing this for more than 20 years. So we see ourselves more as data scientists, and that's why I like to stick to that label. So for the last couple of years, we've had the pleasure of working with Matt and the team on a very, very unique technical solution to detecting mechanical deterioration on industrial machines, which we'd like to talk to you about today. And if I can, I want to share some of the technical foundations of that product and why this is now possible, which wasn't possible in the past. And it really grew out of that wealth of experience that we've developed over the years.
Yeah, and I'd love to hear about that. I think the audience is used to hearing the word AI or the acronym AI. You know, it's really changed our industry, just making our products we use so much more efficient. It's like in a parallel to the audio assistants we all use these days. When they first came out, they were really not that good. And they've gotten so much better over time. And we see that with our vision systems and our code readers, and now in condition monitoring and other applications. It's really helping us get to the next generation or leap to the next level as far as performance and accuracy and actually turning data into usable information. So let me just turn it back over to you guys and tell us about the company. Tell us about your product.
Sure. Yeah. So PRONETIQS. PRONETIQS was founded in 2024, so we've just passed our 1-year anniversary. But before then, as Stefan mentioned, we've known each other for years. And in 2024, at some point, after about 2 years off, I contacted my old business partners and said, hey, I have a concept for an idea for something that I think could be very valuable. And let's see what can come of it. And then sparked a conversation with Stefan. And from Stefan's conversation, we created our first product. Now, what are we doing? Well, this is quite an interesting question. So what we're doing is a slightly different play on, as you mentioned, AI, machine learning. These are big terms and they're general terms. And in general, people think of AI and machine learning, and they think in monolithic terms, large language models, big data, I'm going to do cloud, etc. But our experience at PRONETIQS, which my business partners and I and our team have over 50 years in automation combined, um, that's not always the case for our end users. A lot of our end users, they are looking for an on-prem solution. Could be an edge solution, could be something that's sitting on a centralized computer, where you can easily deploy an algorithm that's going to help them understand what's going on in their process. So that's number one. We want something that's easily deployed from a central location. But on top of that, what we've also seen is that in operations, cost and deployment matters. All countries in the world, companies are trying to say, how can I do this better, more efficient, in a way that I don't have to spend a large period of time just installing the system. And for that, we decided to choose, can we do something in a different way, specifically without sensors? And that's also very important to mention. We can use the control loop data in a sniffing fashion, in a passive way. And based off that control loop data, we can come up with two major challenges that we can help solve. One is identifying wear within mechanical equipment. The other thing that we can identify is inefficiencies within those control loops, thus allowing them not only to identify a potential breakdown, but also identifying which control loops are not operating efficient, and then help them get on the path to operating more efficient.
Yeah, tell us a little bit more about that. So a lot of systems would require you to actually install a bunch of sensors, right? And so that is that takes time. It's an expense, and it's probably more of an expense than people think. Just buying sensors is one thing. Installing a bunch of sensors is a whole nother thing. So be able to use the data that's already there from the control system, I think that's huge. So can you tell us a little bit more about how you do that?
Stefan, why don't you jump in here?
No, absolutely. It's my pleasure to do so. So, Shawn, you're absolutely right. I mean, the value of predictive analytics, the audience knows fully well.
Yeah.
We know the cost of unplanned downtime. So we know anything we can do to reduce that unplanned downtime has tremendous value to industry. The problem with predictive analytics is if you want to do it right, it ends up a relatively costly expenditure. It's a costly project. You need to put data science at work that look at your specific machine and how you're using them within your specific environment. You might need to put additional sensors on, additional computer systems. You need to buy them, you need to manage them, you need to have data scientists develop the algorithms around it. And what you end up with is a very expensive solution that probably works, but then you can't even move it to the next machine down the line because it's most likely sufficiently different that you need to do a lot of the work again. So it ends up being a very costly proposition. And that has prevented a lot of users, a lot of companies that can really benefit from that to stay away from predictive analytics. So what we have done, and we did this on the back of our 20-year experience building exactly solutions like that, we looked for opportunities to bring the data analytics within industrial machines to a level that is common to all of those machines. And now you'll say, well, all machines are different. They all do different things. However, there's one element deep down inside the guts of your machines that is completely the same wherever you go. And that logic is the control logic. That piece that is common to all of those machines are the control systems that control everything your machine does, whether it spins something up, heats something up, cools something, creates pressure, creates a force. All of those physical actions are always controlled through control loops. And if we tackle our solution by watching at the control loops, watching at their behavior, comparing how much they're working to create an effect, we can directly infer the impact of wear and tear. So that's what the core of our algorithm is. It inversely calculates the proportional gains and the proportional effects of the control loops in order to monitor relative changes to their behavior and therefore infer information about wear and tear. With that, we now have an algorithm that we can deploy to all machines by putting a little bit of software on all of the PLCs that are within their machines and get immediate information about the behavior of them and the impact of wear and tear.
And just to give you some real life examples, so what Stefan's really getting to in a simplistic fashion is the math doesn't change. 1 + 1 = 2 in any machine you deploy globally, in any country or factory you deploy. The mathematics are not changing. And because of that, we feel that we have a really advantage over the other systems. We mentioned sensors before, and we mentioned the cost. But what we did not mention is possibly, well, how accurate are those? So in a recent conversation with a client, for example, a potential client, they mentioned that they had spent money with, we'll say, a very large company. The number they had put was between 200,000 and 300,000 euros to put sensors onto drives, which is fantastic for that company because, hey, they're out there trying to do their thing. And we asked them point blank, well, how do you feel it has helped you? And they said, well, we feel it's about 15% efficient. 15%. And for us, we said 15% seems kind of low. Now, their argument was, well, that's better than what we had before. But our argument was you spent several hundreds of thousands for 15% efficiency. And we're much, much lower than that. And we can give you a much, much more accurate efficiency, but we can't give you the granularity that they can give you. But we're not seeking to do that. If a motor or something is going to break, your maintenance professionals or mechanics are already going to know roughly what they need to go and look at. Okay. So to use an example, if you have a gearbox and there are several gears in there, no matter what you do, those gears need to be looked at if we identify that there's something wrong with that gearbox. Telling you that the teeth on gear 5 have now worn off, you're going to quickly see once you take the lid off of that gearbox. So why would you spend all that extra money to tell you exactly that the teeth have failed on gear 5 if you're going to be inside the gearbox anyway?
Your system, I can see, would definitely have a lot of people saying, "Hey, this is our first step. Let's not do this major operation, install these sensors on our plant. Let's try PRONETIQS and let's see if their system will satisfy our needs."
Yeah, in order to do our analysis, all we need to do is passively monitor and observe the behavior of the control loop. So all we need to do is have a way to get the key parameters that describe the control loop and read those at relatively low frequency. So we don't need to keep that data for long. We only need 4 or 5 seconds of observation to make an assessment of how well that control loop works and whether its behavior has changed from the last time we looked at it. So we don't keep your data. We don't need to write to your controllers. We don't influence the behavior of your machines at all. We're strictly only reading. And we're doing that at low enough frequency so we can safely say that we have no detrimental impact on the operations of your machine. And with that little information, completely locally, without an external connection, we can make an assessment of the behavior of the control loop. Let me add one more thing, that all these more complicated algorithms that give you additional insights to, as Matt put it, the teeth on the gear, not only do they cost a lot of money and complexity, but they also make the algorithm much more fragile. So again, they're so diligent about the specifics of that machine that makes it virtually impossible to move it on to another machine without major rework. We, on the other hand, just rely on the well-known mathematics of control theory. That's what we're relying on, and that's universal. That's the same on every machine. That's why our solution will provide the same great results every time, repeatably and predictably.
And regarding the on-prem, you mentioned about that. It's a great thing that we always key with customers is, in today's day and age, we are used to being bombarded with these messages that everything has to be online and you need to have some sort of subscription service to log in from your app. And while that may be in the future at some point, we also look at it that when we're speaking with customers, if they have stuff online at a facility, it's usually a very small portion. So it might be something like a simple alarm that sends out a text message. But in general, I would say just a rough guess, I'm sure somebody out there will chat GPT, try to prove me wrong. I would say the number of facilities that are using a cloud service in a large functional way could be 2 to 5% maximum. I would say the majority of industrial operations are not bringing all of their production data up into the cloud. They're just not doing it. The ones that are, yes, there are out there. They are typically your cutting edge. That's one. But also, you got to think about the world of manufacturing. Everyone thinks about these large names, these large steel mills and these global companies, but there's also a whole bunch of companies out there that are small to medium-sized enterprises. I'm talking about, I have 1 to say 10 production facilities. I don't need a massive cloud service. I need something that's another tool in my toolbox that can be easily deployable. Sometimes we always say it could be same day deployable if the data is available. You can get data out of our system in as short as minutes to say 2 hours. You can already start to get data and understanding of what's going on in your system. That completely changes it for those smaller operators that don't have a whole IT department or 5 or 10 people sitting around just this. And we feel that's a real advantage for us.
Yeah, and I think there's some intuitiveness here from those people responsible for production. Production is king. Um, unless you're doing R&D, production is king, right? And so, we've heard the horror stories, even in an automation and manufacturing, we've heard the horror stories from so many different companies about how, I mean, Toyota's like, that was a massive one, but there's a lot of smaller, just in the US, examples where production was severely, severely hurt by a cyber attack or some type of intrusion, ransomware, whatever. And so I think intuitively, these people ask the question, do we need this? Is it a must? Do we have to be connected to the cloud? Right? You have to have a really good reason, and then you have to have a really good firewall if you're going to connect to the cloud, right? And so that's why we talk about zero trusted a lot on this show and all the different standards. But taking that out of the equation and being able to deploy something where you don't have to put a bunch of hardware in as well, right? I think that really lowers the bar of getting the product in plant and helping production improve quickly. And I think that is for our listeners something they're going to be very interested in knowing more about because, as you lower that barrier to get a working system installed, I've been on deployments where we had to set up a server from scratch. It is painful getting all the software installed. And, it's almost like just buy the server with everything pre-installed, right? I mean, those type of deployments when then you have to, organize people going out in the field and installing all this equipment over weeks and months, maybe as machines go into planned downtime. But your system, much easier to install and implement without all these other considerations. So I'm wondering now, Matthew, if this would be a good time for you to kind of show the audience, at least those who are watching, and maybe walk them through the dashboards you had up earlier in the pre-show.
Well, hopefully everything we've said so far will get those who are not watching to flip on and see what you're doing here. But absolutely, I can definitely show you. I'm gonna just do my window here. The first thing that we want to leave people with is, okay, this is the flagship program. We call it SID5. We have 3 separate software packages. There's a 4th software package, which we brought into our network for industrial network diagnostics and OT, security, but we'll talk about that maybe another time if you invite us back. You need to think of the numbering like BMWs, since it's a European company. So you have 1, you have 3, and you have 5. 1 is designed to be deployed at the machine level. 3 is designed to be for a field service technician. 5 is designed to be the complete facility. And that's what I'm showing you guys right here. 5. Now, with SID 5, what's interesting is the user will log in to the dashboard. And by that, I mean just access it via web browser. And what they're going to immediately see is the current assets that they are having real-time coverage. So you have your assets, your PLCs, your control loops, or your open alerts. And then on the bottom, you have a summary of all of the loops that you are monitoring. This is control loops. And then you have a fleet overview, which is immediately in front of you. Now, with the fleet overview, you can see we're saying a packaging machine, a molding machine, a balancer. But this is just a grouping of PLCs or control loops. So it can be an individual machine, it could be an individual process, or it can be a group of individual devices. So for example, you can easily foresee in here that you would have packaging machine, or you can have in here that you would have a complete process. So this would be a complete conveyor belt. So it could say conveyor belt 1, which could be multiple sections, or it could say pumps, and that would be all of the pumps. On the bottom, the individual can quickly see the open and the past alerts. And then in there, there's a message and a recommended action. And the message and the recommended action is something that the individual user can put in at a lower level that corresponds to the device. They can also type in here the actions that are taken. So in this case, change golf ball. And now this can be acknowledged, and that is now cleared and goes to the past alerts. So the person knows this was taken care of. They can also then click on the machine. They can click on to get more details. So within the packaging machine, you can see that we have controller 1, but you can also see that we have below here the molding machine, a balancer, which is a demo that we use. Now on the molding machine, we have several control loops. We have a feeder, a belt motor, labeling, etc. And those items, we can click on the individual, and then we can see our unique Balaso graph, which is a graph that's showing you the P, the I, and the D. We refer it to that, but it can also be other forms. It does not have to exactly be PID. And then the user can see exactly what each one of those are, and they can click and they can update the chart and go down to the I and the D. So basically, what is the set point and how the system reacts? And then they can see the P, which is the efficiency of how we are reacting to changes within that system. Should they want to go even deeper, they can just simply click on the PLC or the controller, and then they can go down into the individual setup, which is the loop names, where they have to set the act variable set and the control loop. They can record this should they want to do some analysis on the efficiency of the loop, or they can change the alerts and put the actions, etc., for each of the patterns that we recognize. All of this is easily viewable, where they can go to the individual control loop, and there's even the ability to effectively change the tolerance or the time range for monitoring, and bring it all back up to here. So pretty interesting from the standpoint of being able to see the whole facility from a central location. Pretty interesting from the standpoint of breaking it down. We also add one more feature, which is then the ability to pull out reports, and you can do the last day, 7 days, 30 days, etc., to get an alert summary of where the alerts have been generated, where are the trends, and or a fleet dashboard, which is all downloadable into a PDF that the user can then have for their records.
Now, in case you're wondering about the golf ball of Matt's demo, this is a demo that we use to show people how the control theory of this works. And we're getting ready for the SPS show in Nuremberg at the end of the month. So that's why these devices are in there. So if any of your audience wants to visit us in Nuremberg, they're very welcome at SPS for an in-depth show and also to see the ominous golf ball.
Nice. Yeah, I was wondering about that. So that would be excellent. And if you guys can send me a link, if you do any video from SBS, send me a link. I would love to see it in action and working. But in any case, yeah, I can definitely see. So first of all, if you're listening, very modern web interface, modern looking charts, very responsive. And I love the ability to download the report to a PDF, because that may be something you want to share with the boss. Maybe he doesn't want to log in. You just want to say, hey, take a look at this, right? And so you sometimes bringing that to a meeting, passing it out, saying, hey, look, this is what the interface looks like. These are the things we're going to watch for. But also like the ability to go back in and put some feedback in as well. So when you do get that alert, you're putting feedback in saying, and that is being kept tracked along with all the different events that are happening over time. So I thought it was very interesting. Now, having just seen that, knowing that you guys are going to go to SPS, so we're going to get a video of whatever you guys do at SPS, so we can see what the golf ball is. But in any case, what else should our audience know about your company and this particular product?
We're hearing a lot about artificial intelligence and now how it is creating these great insights. I think one of the benefits of this solution is that it's built on solid control theory, which we can explain to every potential user and explain to him why the results that we're delivering back are valuable and why they are correct. I think correctness is one of these important properties that we may have forgotten about in all this artificial intelligence hype. So these are dependable results that are based on solid theory. And the other thing, one comment maybe also about this ability to run in a disconnected fashion, just installed on the island. And we can certainly do that. But however, that doesn't mean we can't integrate. So the results that we're detecting out of individual machines and individual control loops can be integrated back into your maintenance system if you have one. So you can use our dashboard, and of course, we'd like you to. But if you need to integrate your results into your existing backend, that's absolutely possible.
Yeah, and I think that, if we think about what a large language model is for AI, it's really trying to understand people's speech. It's a language model, whether you're typing in a prompt or you're speaking to it. It's trying to parse your words and make sense out of them, right? That is extremely complicated because every individual has their own little slant on things. So that's why it takes so much data and millions and millions of hours of training every year to make these large language models, be able to understand what we're saying, right? Us silly humans. That said, control theory has been kind of like a done thing for many decades, right? And then you guys have been working for this, PID loops, control schemes. This is not something new. I mean, there's always new products that have new features, but as far as controlling a process, the products we buy today, except for maybe our electronics, are almost identical to the products we bought 10 years ago, right? And so you don't need to spend $10 million a year to train a large language model that needs to live in a server farm the size of, a massive, mall or some other large building. So I can definitely see that. And I think that explains more how this can be deployed on the plant floor. Go ahead.
And to use what you're saying, mathematics is a universal language, right? They always say if aliens landed, we would probably speak mathematics first before we would speak native tongue because it's easy to understand. You have, again, 1 + 1 = 2.
Yep.
But it also goes for the same thing of what we're attaching to. So we're looking at what the current set point is. So where do I want to be? We are looking at how is it currently responding? And then what are the mathematics behind it? That's simple. That is completely simple. The user does not need to determine which other factors they need to put in there. We're telling them these are the 3 factors that we need to know to run our analysis. And that makes deployment so much faster. You mentioned large language models, and if you just think about a common language model like ChatGPT, I think they're now on version 5. But this has been now developed for 5 or 6 years, and there is still constantly errors that are found in it. And that's really a problem for operations. Operations, they want a system, again, that they can use as a springboard to move them further down the pipe and become more efficient. They are not looking for another system that is just going to be something else that they need to maintain. They never really utilize it. We're not sure how to do it. We were told this has to be deployed, but we don't know anything about it. And we see that repeatedly over and over again. And maybe I wasn't so descriptive with how the user interface is, but based off of your experience, Shawn, I mean, if you can't understand what's going on in our user interface, then I will definitely fly there and personally explain it to you because it's pretty straightforward.
Yeah, it is. I mean, every company is going to have a little tweaking on the wording of the different lines and products and units and all the different pieces that make up the production, right? But that would be implemented with your language, your process, right? It would be no good to have a bottling plant language in a bakery, right? And so so these things get deployed with your terms that represent your lines and your processes, right? And so once you have that in there, it's so intuitive, right? Because you're saying, okay, I want to look at this line, I want to look at this process, I want to look at this piece of equipment, and you can see how it's performing. And if there is a problem, you can go in there and put what you did to fix it, to resolve it, which I think is awesome. But and I think that's part of the deployment, right? So let's talk about that. So in a lot of times, companies they sell what we think of like a shrink wrap product. They say, here you go, have fun, hope it works. It doesn't sound like that's the way you go to market.
No, in general, the first step is when we speak with a client and they want to deploy it, we have a simple checklist where we walk them through like, okay, we need OPCUA data. Therefore, you must have OPCUA data available. That's kind of a key mark of our solution.
Sure.
But the checklist in general is, I would say, 5 to 10 items for most operations. Where we help them is there's oftentimes a lot of discussions around, I'm not so sure that my product even supports this. So we've already started working with technological solutions for that. So for example, if I'm using an older Siemens PLC that doesn't have OPC UA abilities, but it has step 7, we've done, for example, a technological partnership with Kepware. Kepware is pretty well common in the industry. It's very well known. And we did a pilot project with them, and we showed that you can encapsulate the information from an older Siemens step 7 system into Kepware, and then we just connect to the Kepware server. So this is where I'm saying is we work with the client, because that was client driven. A client came to us and said, this is fantastic if I was using Siemens S7, 1500s, but I'm not. I'm using 300s from, 15 years ago. And then we would work with them and say, let's come to a solution. We are not the type of company that a lot of times we have a tendency to win against, whereas they say, this is my product, take it or leave it, just accept it. We've never been that way. We are customer focused. We are product focused. And then we also take that feedback and we feed it back into how we do product development. Because without the feedback from the field, it's impossible to build better solutions. And if you get a chance to go to the SPS, and we'll try to send you a video, our booth is an old-time English bar. It's always a bar or something like that. And people say, man, you guys must love drinking. And we say, no. That's not the reason why we're doing what we're doing. If we're successful at our solutions, we get you home to do the things that are important.
Love it.
Spend time with your family, catch a game with your mates. These things are much more important than trying to figure out why your system isn't running right.
I love that. That's great. Makes me want to be there. But in any case, now let's say some of the audience, and I know our audience is very familiar with OPC UA. We've had PLC manufacturers on to talk about those features, SCADA companies, HMI companies, and even a lot of the different like Top Server and Omni, so all these different companies that make the OPC UA service for all those legacy PLCs.
Absolutely. And I would love to work with them as well. If you know them, you could tell them to call me. I'll work with them as well.
Yeah, and it's such a great standard because if you have something that's OPC UA compatible, you're good to go, right? So, and of course, I'm a big user of Kepware going back 20, 30 years now. But in any case, if somebody wants to find out more, maybe they're not going to make it to SPS, which we hope they can, but let's say they're in America, they're not flying out there to whichever SPS you're at. But how do they find out more information about this, and how do they get in contact with you if they want to learn more?
Absolutely. So obviously, we have a website where you can go to learn more. So www.pronetics.com. That is PRONETIQS.com. That's one way. For some of the younger users, they may be a little bit more used to social media as a primary focus for getting data. You can always follow us on LinkedIn. We have a LinkedIn page. We're also on Twitter, X, Blue Sky. That's more of a marketing thing than it is for me on the technology product side, but we are there. I would also say, feel free just to reach out to us directly. That can be on LinkedIn, my profile, or it could just be info@pronetics.com. A great way to just reach out to us. And keep an eye out for updates and announcements, because we also know the operational strain that a lot of individuals are under, and they hear your podcast and they love the idea, but then they kind of forget about it. We have other things that come in. So by just simply contacting us now, we can keep in touch with you and keep you updated on what's going on. I would say those are kind of the simplest things.
Yeah, have that preliminary conversation sooner than later, so
Yes.
that you have the information when you're ready to, a lot of times we have to do that.
Correct.
We can't get a project just depending on the funding cycle. Right now may not be the time where you can get something approved, or it's the end of the year. You may be able to use some of that money you haven't spent yet, but better to get the information now, and that way you're prepared, whether you're ready to move forward today or you move forward later. Yeah.
Completely true. And again, being in this industry, not as long as you have, Shawn, but long enough to know that, the time period to get something approved, say 3 to 6 months, that holds true no matter what you do. If you start today, it's 3 to 6 months. If you start 3 months from now, it's still 3 to 6 months. And it's amazing because it's 3 to 6 months to get to a single day deployment. We're telling you we could deploy in a single day if the checklist is complete. but that we still need that pre-work to be done before you can do the deployment. And I can't do that for you, but I can do it with you. I can help you with that. I can answer all the questions. We can get all the technical stuff crossed off. But that timer still is 3 to 6 months. So let's start it today. Why not? What do you have to lose?
Yeah, so you guys are going to be hearing this probably a couple weeks after we film it, but we'll have all the links in the description as we always do. And as we're wrapping up the show, was there anything else, Stefan or Matthew, that we should tell the audience before we wrap up the show?
Believe in mathematics and give this a try. I think AI is a very broad field. LLM is capturing all the attention right now, but there's great stuff that's happening elsewhere as well. This is an area where this is happening, so take a look and explore it. It's another tool in your box to get true predictive information, and we deliver that tool in your box at a very, very, in a very efficient way at low cost and low complexity.
I think that's a very valid point, and we talk about that all the time. We are not here to replace everything you're doing. We're here to augment your process and make it better, make it more efficient. And again, just to say, as Stefan said, we are a tool in your toolbox. Okay. You would not, as a mechanic or a technician or an engineer, go into any facility and say, I'm just going to use one set of mathematics for everything, or I'm going to use one tool to solve all the challenges I have. You would use the appropriate tool. And we feel that we are an appropriate tool for those users that say, hey, I want to know some advanced warning of what's going on in my system, and I want it to be easy to deploy. I want it to be at a very good price point. And I want a company that honestly wants to work with me, not against me. I'm not here to just say to you, this is what you have to do, and there's no other way to do it. Let's open a conversation. I always say the talk is cheap, as you would say, right? But the results can be powerful with the right partner. The results can be very powerful.
Yeah, absolutely. Well, gentlemen, thank you so much for coming on the show. I really appreciate you coming on and bringing us up to speed on what you're doing. And I would love to hear from the audience. Any of you guys out there listening, if you do get the SBS and C and get to meet the folks, we'd love to hear from you. If you have questions, you want to comment on the episode, I can forward them over to Matthew and Stefan. And of course, please find them on LinkedIn. That's social media for business. I think we all know that. But in any case, thank you both, Stefan and Matthew, for coming on the show and bringing us up to speed on PRONETIQS. Appreciate it.
Well, I hope you guys enjoyed this episode. And I want to thank Matthew and Stefan for coming on the show and walking us through how they developed this product and showing it to us and talking about the different ways it can be used. I thought it was very interesting, and I hope you did too. I also want to thank them and their company, PRONETIQS, for sponsoring this episode so we could release it to you ad-free. We're doing a lot of different things in 2026. I had a lot of ideas, different ways people can sponsor us, and some changes we're going to do to the channel. So that will all be coming out in a separate video. I won't put that in this one. But in any case, if you're interested in that kind of behind the scenes, inside baseball type of stuff, look for that video in the next week or two. And with that, I just want to wish you all good health and happiness. I want to say Happy New Year again. And until next time, my friends, peace.